Hello Algebra 1 students, this is Mr. Wilsey, and in this video we're going to be looking at two topics that I know you've studied in middle school before, so we're just going to review them, not spend too much time on them. The topics are proportions and percents. So let's begin. A proportion is an equation that states that two ratios are equal to each other. For example, 3/4 equals 9/12. This is a proportion because it has two ratios, right? 3/4 is a ratio, and 9/12 is a ratio, and they are equal. However, most of the proportions that we're going to be interested in looking at have an unknown. For example, if we had a proportion like this, x/4 equals 9/12, how would we identify what is the value of x in this case? Well, we're going to review that in this video. Now, the way that you probably learn to solve proportions is by cross-multiplying. However, I kind of despise that method because it does sometimes work, but it's not always the quickest, easiest way to solve a proportion. So let's look at some examples of that. So here is a simple proportion. 7/8 equals m/12. Now, let's try and solve this proportion. Now, if you were to do cross multiplication, this is what you would probably do. So just have a thought bubble out here. You would probably say, oh, take the 12 times the 7, which is 84, and this would be equal to 8 times the m, which is 8m. And then we would divide both sides by 8. And so this is, if you use the calculator, 10.5 equals m. However, this introduces two steps in the process. First, we had to cross multiply, and then we had to divide both sides by 8. Really, we only need to solve this proportion using one step. Couldn't you have just taken the original equation here, multiplied both sides by 12? Because we're dividing by 12 and then we're multiplying by 12, so those two operations cancel out. And so all we have left on the right-hand side of the equation is m. And then over here, this mess is really just 12 times 7 divided by 8. 12 times 7 is 84. And then 84 divided by 8, you can use a calculator for that, is 10.5. So this is the value of m. Notice that in this way, we only took one step to solve the equation. Of course, this is just simplifying the fraction here. So cross-multiplying is not wrong, but it just introduces an extra step. So do whatever you're comfortable with, really. So let's look at another example of solving proportions. So let's say we wanted to solve the proportion 20/14 equals 2 minus x/7. Now notice in this case we have kind of a complicated numerator on the right-hand side of the equation. Now if we were to cross multiply, we would take the 14 and multiply it over here, but we don't want to do that. Remember that our goal here is to isolate x. We want to solve this equation for x, which means getting the 2 over here, getting the 7 over here. So we don't want to bring the 14 over to the right-hand side. That goes against our purposes. So really, the first step ought to be just multiplying both sides by 7, which you'll notice is half of the operation of cross multiplying. We're just multiplying by 7, not by 14 as well. So when we do that, these cancel out, leaving us with, let's see, over here, I don't really want to do 7 times 20. What I might do is in my head, I would say, okay, we have a 7 and we're dividing by 14. So that is going to be a half, which really just leaves a 2 in the denominator of the fraction. So we have a 20 left over. Does that sort of make sense, what I did there in my head? It's easier to take a number and divide it and then multiply rather than multiply and then divide, because then you don't have to work with any big numbers. Either way, you could just plug this whole thing into your calculator and get it over with. I'm just trying to show you some methods that might make it easier to do this stuff in your head. And then of course 20 divided by 2 is just 10. Now on the right-hand side of the equation, we are left with 2 minus x. So let's continue solving this equation for x. We subtract 2 from both sides. So 8 equals negative x. Now if 8 equals negative x, then what does x have to be equal to? Well, just bring the negative over to the other side, so negative 8. X is negative 8. Alright, so that wasn't too bad. Now let's look at another example. I know that I'm going through this quick, I'm sorry. Alright, let's solve this proportion. Negative 3 over m equals 2 over m plus 1. Now in this case, we have m's on both sides of the equation. So it's not really going to hurt us any to use cross multiplication in this case, because the m's are on both sides, so it's not like we should favor moving in one direction or the other. So here's how we're going to approach solving this proportion. First of all, we need to recognize that down here on the bottom right, there is an invisible set of parentheses. That is super important to recognize. As soon as we do that, now let's cross multiply. So this is going to go over here, we're multiplying. This is going to go over here, we're multiplying. So the result of that is going to be negative 3 times m plus 1 equals 2 times m. Now as soon as we have this right here is an equation that you know how to solve. You simply distribute the negative 3 into the parentheses, so negative 3m minus 3 equals 2m, and then we can add 3m to both sides. So negative 3 equals 5m, and then last step, divide both sides by 5. So m equals negative 3/5. Okay, so that proportion wasn't too bad to solve either. In this case, I did choose to use cross multiplication simply because there wasn't a preferred direction to go with the multiplication. Alright, now I want to look at a different sort of example. Down here I have a rectangle. Now let's try to find the dimensions of this rectangle using this ruler here in centimeters. So the width is 3 centimeters. So the width is 3 centimeters, and I'm just going to leave off the units here. Ordinarily I would never do that considering how I'm a physicist, but I'm going to rotate the ruler. And let's see, the height of the rectangle, or the length, whatever you want to call it, is 4 centimeters. All right. Now, watch what I'm going to do. I'm going to take my rectangle and I'm going to blow it up. Okay? Now, I was holding down the shift key there, which in this program makes it so the ratio of the width to the length stays the same. Another way to think of that is the diagonals move directly away from each other, right? They move along the diagonal line. I'm not changing the shape like this or anything weird, all right? So I just now increase the size of the rectangle. Now what I want to do is figure out the new dimensions of this rectangle, all right? So let's move on in. Let's find the width. The width appears to be 8.5. And the length, you know what I'm going to do? I'm going to try to predict what the length is going to be. So how in the world am I going to do that? If the small rectangle had the width of 3, length of 4, the big rectangle now has a width of 8.5, is there a way to predict what the length of this new rectangle is? Well, yeah, sure, there is. We need to write a proportion. So here's what we're going to do. We're going to say that the width of the original divided by the length of the original is equal to the width of the new rectangle divided by the length of the new rectangle. Right? Remember, because I said that the ratio of the width to the length stayed the same. So this proportion is true. Now let's plug in the numbers we have. Width was 3 of the original. We're dividing that by the length of the original, which was 4. This is going to be equal to 8.5 divided by the length. All right, now let's solve this proportion. Now in this case, kind of like with the last example, even though I don't really like cross multiplication because it kind of gets you confused a lot of times, especially when you're trying to do something like this. Like if you were trying to take 3/4 times, I don't know, 7/12, if you're multiplying two fractions, a lot of students get confused. They try to cross multiply this. This is why cross multiplication is kind of obnoxious, because it gets students confused about when to use it and when not to use it. You never use it when you're multiplying fractions here, but you can always use it whenever you have a proportion, whenever you have this equal sign in the middle. So I'm sorry, maybe this is confusing, but I'm going to vie for using cross multiplication here. It'll just be easier on us. So here I'm going to take the L times the 3 to get 3L, and then this is going to be equal to 4 times 8.5, which is 34. All right, now once we have that, we simply divide both sides by 3. So the length is equal to about 11.3 centimeters. This is what we predict the length to be. Now, does this answer make sense? Well, let's see. In the original, the length was bigger than the width, and we're saying that the length of the new one was bigger than the width of the new one. So that it kind of makes sense in that way. Let's test it. Let's go up here with our rectangle and actually measure it. So I'm gonna rotate this guy, see how tall it is. Line up my 0 at the bottom, and look at that. About 11.3, maybe a hair less, but it's in the vicinity. All right? So this is how you write a proportion in order to find the length of the side of a shape that is similar to the shape you started with. Now this word similar, this isn't just like orangutans are similar to monkeys. This word has a very precise meaning in math. It means that if you have two shapes, then the ratio of their sides are equal. Okay, so I hope that that problem made a little bit of sense. You'll get some practice with it and be able to figure it out. Okay, let's go on to another type of problem here that uses the same sort of concept. So here we have a tall building. We don't know how tall it is though. We are representing the height of the building with an unknown, x. So it's x feet tall. Now, some things that we do know about this situation. The sun is up here. Let me draw a little happy sun. Here's the sun up here, and it's happy. And the sun's rays are all parallel, like this, because the sun is really far away. Now, because the rays are parallel, this means that these triangles, which are formed by the object casting the shadow and the shadows on the ground, these shapes are all similar to each other. Now think back to what I meant by similar in the last problem. By similar, I mean the ratios of the pairs of sides in each shape are equal. So in this case, the sides that were given, let's see, we know the length of the shadow of the building, we know the length of the shadow of a girl, and we know how tall the girl is. So let's use these three pieces of information along with the fact that these triangles are similar to try to find what the height of the building is. So here's how I'm going to write the proportion. I'm going to say that the ratio of, let's say, the girl's height, 5 feet, to the length of her shadow, this is going to be equal to the height of the building, x, divided by the length of its shadow, 15. Okay, so I now wrote this proportion. Now, honestly, it didn't matter if I wrote it like this or if I wrote it upside down. Either of these would be correct. You'd get the same answer. However, what would not have been correct would have been something like this. 3 over 5 equals x over 15. So this top one is correct. This one is correct. This one is not correct. It is not correct because on the top we have the shadow, and this is the height of the building. These two are not related to each other. Unlike up here, this is the length of the shadow, this is the length of the shadow. This is the height of the girl, this is the height of the building. So the things that are related to each other need to be next to each other. So I hope that explanation sort of makes sense. You'll get some practice with it. Alright, so we have a proportion that works right here. How do we solve it? Well, we don't need to use cross multiplication here. That would introduce an extra step that we don't need. Let's just multiply both sides by 15, because this will make that cancel out. So x equals, let's see, I'm going to do the same trick that I used the other time. I'm going to look at this first. 15 divided by 3, that is equal to 5. And that's going to be multiplying the 5 that was already there. 5 times 5 is 25. So the height of the building is 25 feet. Now, let's go back to my diagram. Come on. Let's go back to my diagram. Does it make sense that the height of the building is 25 feet tall? Well, yeah. 25 is 5 times higher than the girl is. And the length of the shadow of the building, 15, is 5 times longer than the length of the girl's shadow. All right, let's look at another problem here. So here we have a map. We have a map of Florida. Wish I would have had a map of Tennessee, but you know how it is. All right, we have a ruler overlaid on top of this map. And the ruler is measuring out the distance on the map between two cities, Jacksonville and Orlando. The distance between the two cities on the map is, let's see, can you read that ruler for me? It looks like it is 1.25 inches. Now we want to know what is the actual distance between these two cities. Well, how in the world are we going to figure that out? Google Maps? No. Well, we can do that to verify our answer maybe, but we're going to use this down here. We're going to use this scale. The scale will tell us the ratio of distances in the map world to distances in the real world. Alright, so watch how I'm going to set this up. So right now I have the distance between the two cities in the map world. The ratio of that to the actual distance between Jacksonville and Orlando, which we don't know, so we're going to label it with x. This is equal to the ratio of 1 inch to 110 miles. Okay, so I just wrote that down, but look at it and see how it makes sense. 1 inch in the map world corresponds to 110 miles in the real world, and this ratio is going to be equal to the ratio of the distance we measured on the map to the real distance between Jacksonville and Orlando, which is what we want. Okay, so what I'm going to do to kind of simplify this is get rid of the units, because the units help us to make sure that things are lined up properly, inches and inches, and over here this is going to say miles. But as soon as we get the units cleared up, I'm just going to erase them just so that it makes things a little bit easier to work with. Alright, again, here I'm going to kind of go against my better judgment and use cross multiplication. Watch what I'm going to do. X times the 1 means x times 1 is just x, and then I'm going to cross multiply in the other direction. 110 times 1.25. 110 times 1.25. Let me do that in my calculator real quick. 10 times 1.25 is 137.5. All right, that's it, right? Because we found what x is. So the real distance between Jacksonville and Orlando is 137.5 miles.